Hello everyone, it's a pleasure to be introducing our submission on behalf of the team at DARC, DARC being the Digital Architecture Research Centre at Kent School of Architecture and Planning. So our submission is based on Friedrich Kiesler's perception of space and the idea of continuity. Our design proposal follows a nature-inspired scheme discussing the notion of continuity of force through the study of combined loading. And having set up this framework, we decided to run a student ideas competition with the ambition of receiving some excellent design ideas and potentially some extravagant design proposals. So having instigated a student design ideas competition, DARC structure is inspired by Kiesler's Endless House, where he expresses concepts such as connectivity, co-reality and biotechnique, and the notion of continuity in the form of a line for which both ends meet. With the shape of the Kiesler's Endless House resembling roughly a flattened spheroid, the geometry can also be seen as an eggshell envelope with seamless curvature. And given that biological systems may suggest solutions for technical problems, and that a standard optimal solution can be achieved by using different strategies performing optimally under specific circumstances, the proposed design is an expression of natural continuity that blends with the architectural brute force.
Following Kiesler's ideas, the proposed design is an expression of natural continuity that blends with the architectural brute force, and strain is explored sequentially in all of its forms: axial, shear, bending, torsion. This combined loading approach as a design decision is achieved through a nature-inspired scheme with imperfections and asymmetries, resulting in a structure in state of self-stress. The structure consists of an outer layer of birch plywood members pulled inwards with wire ropes. Rope ends connect at a triangulated mesh of wires in tension. The internal mesh is being stressed at the end of the assembly and then pulls the outer 38 cables connecting to the beams. Force is carried through a combination of bending and torsion in the outer beams and through pure tension in the wires. This follows a nature-inspired philosophy of different types of properties in biological structures. Ultimately, the structure is in a state of self-stress, manifesting the principle that the global behavior of a structure can be seen as the product of local actions. In Kiesler's terms, continuity is expressed as the strain is being carried along the structure in different forms. The connecting wires between the two main structural layers carry a series of fabric VORONOI-like cell shapes. Each cell is individually lit, and proximity sensors provide input for color values. Aiming to explore directions in pedagogical and intuitive approaches in structural design, geometry-based design tools and original graphic statics methods are used to determine axial forces, bending moments, and torsion, and also deflections. It is an objective of this project to explore the limitations and challenges of geometric and non-conventional solutions in structural analysis. Kangaroo was firstly used to create a simulation of the internal wire mesh behavior following the observations on a first prototype model. A Doo-Sabin mesh triangulation method was explored to seek relevance to a 3D Rankine force diagram reciprocal. Following advancements in graphic statics for the design of frames, geometric methods for constructing bending moment and torsion diagrams on designated load paths were implemented here. This approach, based on a loop element that can be orchestrated for composing both the form and force and moments diagrams, is applied here, and a series of such loops are constructed to visualizing bending and torsion. Back to the discussion on Kiesler's continuity, each loop expresses the main design concept of combined loading being carried along its curvature. Different sets of loops carry the force of their connecting wires with their corresponding bending and torsion. Superimposing the loops provides the total bending and torsion values that are used for checks on the structure's cross-sections. Since torsion maximizes shear stresses, material properties provide a maximum allowable shear stress parallel to the grain value for the check. Interestingly, The calculated shear stress approaches the material limit, a fact that highlights the overall delicacy due to the small cross-section and also the significance of having the ability to examine torsion effortlessly with the graphical method. Further developments in graphic statics also have reintroduced the use of the conjugated beam method for graphically determining deflections for cantilever beams. An original application was implemented here, and bending moment diagrams are used as force input to the conjugated beam method. The resulting deflection diagram provides an intuitive reading of the structure's behavior, and this can then be juxtaposed to an OASIS GSA analysis. Notably, the latter lacks the multidirectional aspect of bending moment diagramming that the graphic method offers. Concluding, expanding the application of graphic statics methods in architectural morphologies beyond their mere relevant vocabulary provides insights on the geometric techniques themselves, and bio-inspired designs offer a rich framework for such an experimentation.
The lighting of the VORONOI draws inspiration from nature and the attraction that flowers and plants can have on some animals and insects. Each cell of the VORONOI is individually lit by a unit constructed around the VORONOI's structural wire system. Each 3D printed unit contains a series of LED lights that cascade through a spectrum of colour. The 38 cells combine to create a dazzling display of colour, luring spectators in. However, mindful of the pandemic conditions that we have all been working under in recent months, a series of proximity sensors placed around the structure sense when spectators get too close, and will send warning signals changing the ordinarily serene colours into vibrant red. These colours then return to normal once the intruders retreat.